Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for January 20th, 2026. Tonight we'll do our normal presentation of projects and then roundtable discussions for anyone that has questions or stump the club or just something of interest. So we'll start off with a little bit of housekeeping. The DPRG will be holding its annual membership meeting next Saturday, January 24th at the Dallas Makerspace. The agenda will be the elections of officers for 2026, brainstorming session for what members want the club to do in 2026, such as tech talk topics or anything else. If you have anything to show and tell, you're welcome to bring a robot or miscellaneous stuff to show off, possibly trade, sell. And a list of candidates was emailed out to the DPRG list server with the instructions, I believe, went out as well to the paid up members on how to vote. So vote early, vote often.
So yeah, to add to that real quick, Pat. So yeah, for those in Dallas, obviously with the weather coming in this weekend, don't risk it. If it's wet, icy, slushy, whatever, stay home. We're going to have it online regardless whether we're there or not. So stay safe, vote online, and we'll get through it. There won't be any pizza virtually, unfortunately, but you know, you'll be safe.
I've been waiting every Saturday for my pizza delivery for a couple of years now.
one of these days, Pat, you're gonna get a knock at the door. So yeah, so stay safe, vote online. I think Paul sent out the link last night, I believe, to the list. So check your emails, and yeah, I'll keep updating people throughout the week, see how it is. But yeah, that's all.
Thanks, Mark. Okay, presenters. First up tonight, we have Trish with an update on the weekend's competition.
Okay, there I am. Okay. All right, so this weekend, me and my 8 friends, so the 9 of us, put on an enormous robotics competition in Dallas at the Irving Convention Center. We had 92 high school teams come in from 10 different states. Mike came to help judge, Harold came to help judge, David came to help judge, and Colin from the UTV VAX team came in to judge. Mike even came and helped us set up. We were there from 7 o'clock in the morning on Friday until midnight. He stayed for most of that to help us build fields and build platforms and stuff. That was awesome. I don't know what else to say. It went really well. All of us judges, I was in charge of the judges, so the judges were doing interviews with the teams to try to figure out exactly what they've done and how they did it. So probably Mike or Harold or David would be good about talking about what the teams had to say. We reviewed their engineering notebooks. They were amazing. They're actually so amazing that we're going to have to revise some of the rules because even though we're only, it's January, we're just a few months into the season, and some of these kids had notebooks that were over 1,000 pages long. So we're going to have to change the rules so these kids can learn how to discern what is applicable and what actually is process of design along, not just throwing it in there to look good for somebody else. Okay, so we had 22 judges show up. So we had 22 engineers that had to agree on who would be the award winners out of 92 teams that we talked to. It took 6 hours. So we spent all day Sunday, literally all day Sunday, trying to figure out who the award winners should be. And they did eventually decide. And it was a really hard process because there were such good teams there, and just the ideas that they come up with and just all of the different iterations that these kids did, it was just really great. But I don't know what else to say. I know my kids' team got a spot for the World's Championship, so that was awesome.
It's awesome. I watched some of it online on your YouTube live, and it was really fun to watch.
Yeah, this year's game is really fun because you never know who's going to win all the way up until the end because they can descore. So they'll get all of their blocks on the scoring goals, and then another team can just come in and wipe it out.
Knock 'em off, yeah. Yeah. I did see some with like sticks that would like combine to like push all the balls. I was like,
Yes, it is very stressful.
yeah.
Okay, so I don't really have anything else to say about it. If anyone has questions about it, I'm happy to answer because this has been my whole life for the past year.
I guess when's the next one?
We don't know yet. We're going to do our debrief on February 1st and try to talk about dates. One thing we don't ever want to do again is host another event like this right after the holidays, because trying to get in touch with all of our vendors and our volunteers over the holidays did not work.
Smart. Yeah, right. Well, cool. I look forward to the next one. Hope I can make it.
Yeah.
Sounds like it was a successful event.
Yeah.
Yes, it was. Actually, NBC5 came out, so we've been on the news, like kind of in their rotation. So that's been pretty cool.
So do you have happen to have a link to the NBC5 news?
Yeah,
Maybe some of us that are remote can watch it.
Yep.
Yeah.
I was wondering how you were going to pull that off with 92 teams.
It was really hard. And usually we have experienced judges and we all know what we're doing. But this year, since they changed the rules on us, so we couldn't have judges that had affiliations with teams and we had to use all brand new people, we learned a lot about what we don't know. So I learned a lot about my shortcomings as the information that I provided for these people to get ready.
Well, I want to say congratulations. From what I read in the, I think it was the Discord server and the DPRG list, it went very well. And congratulations to you and your team and judges and everybody that worked, the volunteers.
Thank you. Okay, there we go.
Thank you. Anyone else have questions for Trish about the event?
Yeah. Are the platforms like VEX component based, or is it kind of a mix? You know, can you use?
Yes, so VEX requires all the students to use VEX cards only, and that's kind of their way to be an equalizer. So there can't be a team that can do like a pay for play type of thing where they can come in and just buy stuff that is way better than any other team can afford.
So what level of sophistication are the platforms? Are they using Raspberry Pis or LiDARs or?
I don't know exactly. I don't know. So they just call it the brain, and I don't know exactly what the brain is based on.
Oh, okay.
I don't actually get to do very much with the robots because the adults, we're not allowed to help. We're not allowed to touch them. And
Oh, wow.
I'm involved on the administrative side. So I'm so busy actually organizing things and planning things that I don't get to actually touch the robots.
Okay.
Okay, well, thank you, Trish.
Thank you.
So that was it for our formal list of presenters. Does anyone else have something they'd like to bring up?
I'll mention I've just started to tinker with April tags.
Uh-huh.
Don't have anything to show yet. I've decided I'll start at the low end, so I'm proceeding to run the demonstration software on an ESP32 cam, and we'll see how that works. Apparently it works quite well based on the demonstrations I've seen, but so far I can't get it to compile. So we'll see where that takes us.
Do you know what kind of frame rate you can get with the USB cam?
Yeah, 5, you can, according to the demonstration that I saw on a standard AI Thinker ESP32 cam, you can do 5 frames a second.
Oh, that's not
And
bad.
and that's with a 6x6 matrix.
Mhm.
The particular example I showed you is a 4x4 matrix,
Mhm.
and those process faster. I don't know how much faster, because it's a simpler thing to do. So
Yep.
we'll see where that takes us. But first I have to get the compile to work. I don't know why yet. Theoretically, it's Stephen is not here, I don't think. Last week he showed the use of April tags running with a Raspberry Pi on his new robot. I was going to ask him what he thought about that. I took a look at the use of April tags with the first Robotics Challenge stuff, which was also mentioned last week. But that's way, way, way out of my price bracket. So we'll start at the low end and see what happens. I can put that on a Raspberry Pi if I have to, but I shouldn't have to.
I want to say in the God, what is it called now? Yeah, haven't used it in a while. Forgot. I do have an icon on my laptop though. That'll tell me.
One of the products available for the first Robotics Challenge for implementing April tags with a complete camera subsystem is something called Lighthouse, I believe. Very, very expensive implementation, but they offer some really nice free tools on their website to do things like create April tags. And I thought that was pretty cool since I had to create some and print them.
On the it's the OpenMV IDE. If you look at their example for April tags, there's a little, highlighted text that you can click on, and it'll take you to, I guess, some I don't know if they're PDFs. I haven't looked at it in so long, but you print them out, and I did, and they look pretty good.
Yeah. I think Stephen was using the OpenCV version of April tags, which for some reason has a slightly different name attached to it, although apparently the implementation is the same. So I don't know if there's a copyright issue going on there or something else.
I sort of always question what's the difference between the April tags and a QR code, because some of the QR codes are fairly simple as well.
Yeah, well, QR codes most of them tend to be fairly complex. They contain a lot more data, but they're not intended to be used for any form of position location information. QR tags are just QR tags. They're intended just to read the data, and a lot of it if you need to. Oh, yes, I see, Ray.
Yeah.
So if you wanted to determine the distance away or the angle with a QR code, that is more difficult to do, because they're not really designed to be able to do that accurately.
Okay.
April tags, and there's half a dozen different variants of April tags, many of which came before the April tag, and they're designed primarily to be able to get very simple processing, to be able to get, I think of it as pose-related information, and a little bit of identifying information.
Do yours have the border around them?
The tool I use to create them gives me the option. Now, when you're showing a border, no, I chose to print mine without a border.
Yep.
The only part of the border that's important, you can see on mine, it has a one cell wide black all the way around.
Yeah.
That's important for purposes of analyzing the QR code. I don't know why they offer the second border. I haven't run into that I've read the two of the major papers that describe the physical and mathematical implementation of April tag designs. Yep. And there's no requirement for that additional outside frame. So I don't know why it's there.
Yeah. I know there were these were two different complexities. I mean, this is I forget what the 16H5 means, but it's a certain size.
16 bits, 4x4 with a Hamming code of 6 is what it means. And the Hamming code relates to how easy it is to detect errors when you read them and how easy it is to correct the error if you want to correct them.
Oh, okay. I probably read that somewhere, but have since forgotten it.
So that'll give you distance to the tag as well as like a offset angle to the tag.
Exactly. It gives you both of those things with very good accuracy.
Okay.
Yeah, I thought
Distance
maybe the border
within a
was
few millimeters, angle within a degree.
Okay. So with 2 or 3 tags, you can get good localization.
Mhm.
Exactly, Pat. I was amazed when I read that.
Yeah.
And
I thought maybe
implement it with an ESP32 cam. That's a really cheap implementation.
I thought you could use, or I thought the reason why the border was around these is you could do like, aspect ratios and figure out how far away it was.
And that's true, but you only need the first border. Hold up your picture again.
Right. The
Okay.
inner border.
You'll notice that in the inner picture is all black all the way around.
Right.
That's the only border that's required for processing.
Yeah.
Not the outside one. I don't know why it's there. Maybe it's to guide your scissors when you cut them out. I don't know.
Don't know. That's an awfully fat guide, though.
You do have to have the white space around the outside. So you'll notice on my picture,
Oh, okay. Yeah.
this generator, let's see if you can see it. You
Yeah.
may be able to see there's a very faint black line around the outside. And the reason
yeah.
it's there
Yeah.
is because it defines the fact that there's a white border around there.
Right.
The white border is used along with other information to perform contrast assessment. In other words, these things need to be read no matter what the lighting conditions are.
Mm.
And the logic that reads them will perform localized calibration of the black to white ratios. It's very, very sophisticated stuff. When you read through the papers, they'll tell you a lot more about how it works.
Yeah.
But really cool stuff. So that's what the white, there's actually a white border around the black border. And it's part of how they perform contrast measurement.
Can you change the lens on your ESP32 camera?
Not the ones I've got.
Oh, okay.
Things don't have any ability to. In theory, you could. I mean, they're kind of stuck in there somehow. I don't know how, and they have a little knurled ring around the outside of it.
Mm.
But I don't have any lenses to replace them with.
Yeah. Maybe
I'm not
break
sure
that
what
one,
I
right? Yeah, I got the ones with the 12 millimeter. It's kind of like a barrel lens. So you can screw different lenses into the lens holder,
Right.
which is kind of nice.
Yeah.
I
looked at getting some of those lenses for, like, I have several Raspberry Pi cams as well. And I looked at getting the higher level cameras with the changeable lenses for that.
Mhm.
But the price starts to go up rapidly, and I couldn't see any reason to, so I didn't.
Yeah. Kind of what I found is if I used a wide angle lens, it reduced the distance away from the April tag that you could actually detect the tag. So with like 180 degree wide angle lens, you had to be 5 feet or less away. And, that doesn't work with the course that's 10 feet long so well. So
The April tag research lab published 3 papers over about 7 or 8 years. And the third paper in the series gets into more advanced configurations of April tag designs in order to accommodate specialized uses. And one of the uses I thought was really cool. You can hold up your pattern again.
and there's several.
They provided a modified description and a modified reading software for these things in order to allow the center cell to not be included in the read. And instead, what it allows you to do, which they show examples of in their paper, is they print the April tag like you've got it, very, very large, and they use it for being able to detect an April code from a long distance away. And the example they're using is a quadcopter, which is looking for its landing spot. And it wants to see it from way up high. But you also want the quadcopter to land right in the center of the landing field. So what they do is they print a second QR code that fits into the white space in the center of the big one.
Oh, wow.
So as the helicopter gets closer, right, the camera's zooming in physically, so
Right.
it can't see the whole code anymore, but it can see the little one in the middle.
I'll be darned.
So they built this cascading mechanism for printing and detecting QR codes. They also showed some examples of April tags being used to track insects. Some biological research into swarming behavior and cooperative behavior on the part of ants and bees. And they show photographs where people have printed little wee tiny April tags and delivered them onto the animals.
Yeah, I saw something
I
about
figured out how
that.
to do that.
Little teeny April tags.
Yeah. And circular ones and other oddball shapes, so they fit better on the bodies of these little animals. That's pretty cool. That was the third paper. It doesn't really get into any improvements in the basic mechanism, just specialized applications. The first paper and the second paper, which are 2011 and 2017, I think were really, really good.
I ran into an issue with M12 lens lately that I, just let people know. You can buy cameras that have M12 fixtures on the front of them, or mounts. I guess the correct word is a mount. And unfortunately, the M12 lens don't have any sensor to bottom of the lens standard. Like when you get a C1 mount, the distance between the sensor front and the lens end is supposed to be a set distance or something. But the M12, depending on, let's say you buy an M12 camera that's got an inexpensive one now. I'm not talking about, you can buy a Raspberry Pi camera with an M12 mount, and it's very versatile, but it's also $35. But some of these cheap $12 cameras, they don't make the M12 mount screw distance long. Otherwise, the distance that you can screw into is not long enough for telephoto lenses. So if you think about it, the telephoto lenses, the back of the lens to the sensor front is got to be a set distance. Well, if the camera came with a pretty much a wide angle lens, then if you go to a telephoto lens, you may find that you have to screw it all the way out and it still didn't focus. And you can, if you come out a quarter inch beyond that, you find it would focus. So what I found is if you're using the 25-degree lens, you've got to have, which gives you about a 12-degree horizontal VOF. You got to have a lens that's got a long thread in it. Now it turns out that they're also, the sensor size has effect on that, because these lenses are actually made for a certain sensor size. But like for example, the Pixie Cam, it has a lens that I want to say it has a 40-degree horizontal. I don't remember what what they say their telephoto, but it's essentially a non-extreme wide-angled lens, and it's those screw barrels are too short to put a telephoto lens in. So I'm just saying is, if you're buying M12 lenses, you go to the higher telephoto lenses, you can run into an issue. Now, for most of us, we want we want a large HVOF. We want like a 40 or 50, so that we can see a distance, an angle. But if you were like monitoring a mailbox, for example, then you would probably want a telephoto lens, because the target's stationary, what you're monitoring with is stationary, So you could go with a telephoto lens in that case. So, and I also found out that, like I said, the $34 or $45, I can't remember exactly, Raspberry Pi cameras are very nice. They have good sensors, they have big sensors, and they take almost any type of M12 lens. So anyway, just know that you can buy an M12 camera / lens combo that doesn't work. Just something to think about. So if you're buying from Amazon, so you can send it back, yeah.
Yeah, I know. The OpenMV, they sell a couple different lenses. One of them is a telephoto, so hopefully they've looked at that before they.
Well, I'm sure they have. Yeah, I'm sure they have.
Yeah.
And like I say, there was no problem on the Raspberry Pi, and I think, Ray, that the more expensive cameras usually have bigger sensors.
Yeah, that's like 1/4 inch or 1/3 inch.
Yeah, something like that. And I think that helps the problem. Anyway.
Yeah, I kind of settled on a wider angle lens for like 6-can, because that made me move the robot around, and if it didn't see a can in the field of view, so with a wider field of view, I didn't have to move it as much, and because the movement was kind of slow, I only moved 5 degrees at a time.
Well, the other thing you run into that you have to be aware of is with the focal, the field depth of field on telephoto lenses is much reduced. So, if you have one that's focused at 5 feet, for example, 10 feet is going to be fuzzy. So, I mean, if you're blob detecting, it's not a big deal. But I'm just saying you have to be careful that the depth of field becomes a player in it. Also, usually those ones don't have as much light transmission. So, high power, basically.
I was wondering how that would work with April tag detection, like Ray was saying, at a couple feet versus 10 feet.
Yeah, I don't know, Tom. How out of focus can you be before it's a problem?
Yeah, good question. I was going to touch on that. When you have a look at the papers that the Robotics Research Lab did at U of Michigan, where they developed this stuff, the papers go into, among other things, that exact test. Because what they were attempting to do is to optimize the way their software and its underlying mathematical principles operate in order to ensure maximum range. For example, they can read I'm trying to remember the numbers. They can read 4-inch square April tags in excess of 20 feet away. Now, the camera they're using also works down to about a half a meter, around 2 feet away. So they were able to get extremely good range out of a relatively straightforward webcam, because they basically plugged the webcam, a Microsoft webcam, into a desktop IBM PC, a Windows computer, to do their testing software. And one of their tests said, over what range does this thing work? They were attempting to optimize the code so that it could do discrimination where the distance between the black and white pixels, or between two adjacent black pixels separated by a white pixel, where a pixel is those square elements in the April tag, where that distance was only 1 pixel, where the amount of pixels they've got in the camera image is typically on the order of 640 by 480, conventional 15 years ago webcams. In my book, that's pretty impressive stuff.
Yeah.
They then tested these things for accuracy at different ranges. If you wanted to know more about it, Pat, have a look at the papers. They're extremely interesting, a little bit mathematical, but they're very, very readable. The test results are are very, very easy to understand.
Well, the math might give you a little bit of problems.
Yeah.
70% of electricians are mathematically illiterate, almost half of us.
Well, they have plenty of pictures in the form of results graphs, and they're in color.
All right, then it's up my alley.
Yeah, that's all I go by is what did I wanted to read through the math to see how they derived this stuff, to get a feeling for how complex the software would be that they wrote, the libraries. And they go through the exercise of how they simplify the math, primarily because they want really good execution times, and they don't want to consume a lot of memory in the process of building things like data matrices as they analyze the results of a video image. Lots and lots of material in the first two papers, highly recommended for anybody who wants to know the details.
Mm-hmm.
Otherwise, just go get the libraries and use them.
Well, it's something to take a look at. Give it a go.
Yeah, like I said, I was just amazed at what these guys were reporting as a result of their testing in terms of accuracy, range of motion, speed of computations. Really impressive stuff. We'll see. We'll see when I get one running. That'll be my proof.
I happen to have an ESP32 cam as well that I've never put to use. So it might be something to look at, to a little playing around with. Well, thanks, Tom. That was a good topic.
We'll see where it goes. I see interesting things possible with it. Like I said, Stephen's not here, and I wanted to know how far he had delved into this when he decided to use April tags for his demonstration last week. I know he used the OpenCV version, but it's basically the same thing.
Yeah, he was pretty close, I think. So
yeah.
It seemed like his April tags weren't that far apart.
Maybe to keep them within his camera.
Mm-hmm.
Yeah, he was running back and forth about 10 feet apart, wasn't he?
What's that?
He was running his robot about 10 feet apart from the two April tags were about 10 feet apart.
No, not even that.
Yeah, I didn't think it was that much.
Okay.
Yeah.
Cool.
It seemed like maybe, I don't know, maybe 4 feet apart.
And there was some discussion of the use of April tags in the first Robotics Challenge robots last week as well, which also got me intrigued. And they indicate that they're seeing very good results out of their implementation, but we don't know very much about the details of what they've actually implemented or how much code they wrote. And based on some of the reviews I did a few days ago on the first robotics have very good online documentation of lots of systems. And from the little bit that I was reading, it's mainly a plug and play kind of situation. So I don't know how much they have dug into the inner workings or the inner application of those things. But they were reporting some indication that they could get interesting range and angle numbers out of them. Well, the only other thing I've been doing that kept me away from robots is my end of year workshop cleanout of all the things that I should not have kept anywhere near as long as I have kept them. I mentioned a few weeks ago selling off some of the really old motherboards I had. And this past week, I managed to sell a box of 13 of what I call turn of the century IDE drives. People give me stuff and I pull out what's useful and junk the rest or recycle the rest. So I had accumulated an enormous pile of hard drives. I kept only the IDEs. I got rid of the non-IDE earlier drives a long time ago, mainly because I liked the big magnets that were in them. So I would take the big magnets out of them and throw the rest away. But I kept all the IDE drives, and I had IDE drives down to as small as 400 megabytes. That's a really small IDE drive. So I figured I better get rid of them. So I tested them all. They all work. And I wiped them where they had recognizable files on them and put them up for sale on Marketplace and had 4 buyers within a few hours. 2 of them in the States, but sorry guys, but Trump's tariffs make it impossible to ship to the States these days from Canada. So I finally ended up selling them to a guy in Chilliwack, British Columbia, which is some few thousands of miles away from where I live. Shipped them by Canada Post Surface, and they arrived very successfully there. He's very happy to have turn of the century IDE drives because he and a club he belongs to in Chilliwack are into vintage computers. And this was a real find for him. So a real win-win-win. I cleared out a shelf in my workshop, and I put some money into my robot fund, and he's ecstatic to get real cheap working drives. So.
Well, that's funny, Tom. My son, who lives in Seattle, collects he's trying to collect one example of every Seagate series.
Okay.
Otherwise, he says, he looked at all, he can talk hours about IDE drives to you, and he does things like, does low level sector reads and all this, stuff that I don't even know why you would have any, why would you do that? But
it's a hobby.
But apparently it's a big thing for people who are kind of into retro computers. And so like the ones you took the magnets out, you probably could have had a small fortune because those are like, like gold.
I know, I've thought of that myself.
Yeah.
I had a bunch of 8-inch floppy disk drives from the very first computer I built in the late 70s.
Yeah.
Back when I paid $250 each used for them. And when I stopped using them and they were taking up too much space, I took them apart because I wanted the stepper motors, and I threw the rest away.
Yeah.
I could get $1,000 each for them now.
Yeah.
Oh well.
The smallest hard drive I ever had was a little tiny. Remember the compact flash, the little square chips you could put into cameras at the time and all sorts of stuff. I had a mechanical hard drive that was that size.
Wow.
I think I still have it somewhere in the garage. It's just a little tiny mechanical. I don't know how big it was.
All I know is that the first hard drive I got was 5 meg, and I was proud of it because before that I was using these, using floppies, and you had to have a machine instead of a hard drive. It had 2 floppy drives,
My first drive was 10 megabytes, and I was so amazed having moved up from 2 floppies.
Yeah.
10 megabytes and no way to possibly fill it at all.
That's right. That's right. It was infinite.
Yeah.
Yeah, my first drive was 40 megabyte, and that was when I went to college at New Mexico Tech.
Yeah.
And at the time, my 40 megabyte drive was bigger than the total drives that they actually had in the computer science department at New Mexico Tech.
Well, the first real-time plant automation computer system I worked on in 1975 had a 1.5 megabyte rotating drum memory. 1.5 meg, probably cost $50,000.
Yeah, I was going to say, Tom, now you're talking about rotating drum. I never even heard about those. Well, apparently my son, in his collection, has got one of those, and he's trying. There's some issue with it that he's trying to resolve. So he's, like I say, I don't know. It sounds like a time sink from hell is what it sounds like. But anyway.
Okay, we're under gig drives like 94 or so. We're under a megabyte. Was that like 94, 1994?
Under megabytes. The first one I saw was 5 megabytes.
Oh,
That's-
okay.
That's when I got one, and the biggest problem with them was you didn't want, you can imagine how unstable Windows and stuff were at that time, and anytime they would stop, the chances of screwing up your hard drive like really bad because they didn't auto park. It was oh man, it was a scary time.
The flying head no longer flew.
Yeah.
Yeah, I remember that. You had to have a park routine on your on shutdown.
Yep.
And if you
Yeah,
crashed, you never ran the park routine.
Yeah.
Ray, to give you an idea, my 40 megabyte drive that I got, that was back in 87.
87. Okay. Yeah. Yeah. I kind of remember, God, they were Hewlett Packards, the laptops, had a little 640 by 480, color screen. But I thought the drives were like under a megabyte. Like 700 something K, I think was the smallest one. And
740K?
maybe it was 740. Yeah. Was that a common
3.5
size?
inch drive?
What?
A 3.5 inch drive, or a 5-inch drive?
I think they were 3.5s. Because it fit like in the center of the laptop.
Okay, so maybe because the original, I think 3.5s were 740, and then they doubled the capacity on them to 1.44.
Yep.
Yeah.
Yeah. My first computer that I had a Radio Shack TR80 or whatever it was, but there was no way you could have a hard drive in that one.
I had infinite space on those. I had a whole deck of cassette decks, man. I had all the space you could ever want.
Yeah, but the first real computer I got was the Texas Instruments Professional, which was 83 through 85. So that was when I got that first one with that 5 meg hard drive, was in that time period.
Okay, Xerox Corporation came out with I guess you'd call it a desktop. It was I don't know if it was, I want to say HC08 or HC11 based, and it had, you could get a floppy drive controller for it, green screen tubes, monitors. Does anybody remember that setup or see that somewhere or use it? Tom does. Yeah.
I remember green screen monitors.
Yeah.
Yeah, I preferred the ambers when they come out because they weren't green and they had that cool amber shade.
Yeah, those two. The Hercules card.
Yeah.
Yeah. Yeah.
The page white displays were nice when they came out.
Yeah.
A lot easier on the eyes.
Yeah.
Okay, there was a name for the Xerox operating system. Tom, do you remember what it was?
Oh yeah.
For Xerox?
That's what-
No.
No.
That's
Okay.
the one that Bill Gates got his, what is it, like CM something?
MS-DOS and PC-DOS.
No, that was his, that was the second. That wasn't where he started. It was the one before that really, if you looked at them, you could see that they were related. You know what I mean?
Well, CPM's been around a long time. Maybe that's what you're talking about.
I think it was CPM. Yeah.
But anyway, enough about old computers.
Yeah.
Yuck. Yuck. Don't want to go back there. That's why I just get crazed when I see these people doing the retro stuff. I mean, I'm just like, oh man, it's so bad. You don't want to be there.
Oh,
One of my first computers.
Yeah.
That's some S100 boards.
Oh yeah.
So actually this one, I forget, this is from so long ago. Might have been 1802s. But before I had computers, I had that.
Oh yeah.
That's a TV typewriter that I
Yeah.
built myself, and a modem I built myself. You'll notice the tomato juice or the tomato soup cans sticking out of the top of the modem.
Oh yeah.
that system still exists and still runs. It's in a museum in Squamish, BC.
I've been to Squamish, BC, but not to the museum.
Yeah, you can see it online. A Facebook page called The Tech Traveler. The guy runs he's got the physical stuff in his house, and he's got videos of all the things he has accumulated. So he's got my Tiki typewriter.
Yeah. There used to be a retro museum in Seattle that was started by one of the Microsoft people, founders, and he died. And when he died, his wife basically shut it down and sold all the stuff. But it was apparently you could go into this museum and you could actually program on any of the computers that they all worked. And you were allowed access to them. I'm sure you had to check in or something. But anyway, it apparently doesn't exist anymore. And some other people in Seattle are trying, people who worked at the museum, which I think was more of a labor of love than money, are trying to gather pieces of it and put it back. But anyway, just an aside.
I posted a link for Tech Travel, but I think it's the wrong one. So just
I'm
ignore that link.
I'm just looking for it now myself. It's the first one I got was the wrong one.
Yeah, my bad.
Well, Seattle may have had their museums, but what do we have? The video game museum?
We do. That's pretty impressive too.
Pretty obscure, you know.
Yeah, I do love going there.
If you're ever in the Bay Area, the Computer History Museum is a good one to go to.
Yeah, that sounds like it'd be fun. I'm sure if it was in San Francisco, it'd be pretty awesome.
Yeah, it's in Mountain View, close to there.
Mhm.
But they have everything from the old PDP-11s all the way up through modern computers. They have several robotics things in there as well. A lot of the HP history, because HP was a big one in the Bay Area. A lot of Intel stuff. But they have just about any computer you can imagine they have. And most of them are actually working and running.
Mhm.
Nice. Yeah.
In '97, I installed a 8-foot veneer line in a plywood plant that used a PDP-11 for the optimizer.
So
And
is
it was-
that DEC Digital Equipment Corporation? Was that who was making the PDPs?
Yes.
Yeah, I think it was either a 1 meg or a 10 meg drive. But this thing, the platter, it had a removable platter and a fixed platter. And the removable platter was probably over 12 inches in diameter. It had a huge locking handle that you'd set in this pretty good sized box that was on slide, heavy duty slides. You pull it out, stick in the platter and lock the handle. But it was only, I think, 10 meg. That was like 80. No, actually, it was late 70s, like 78.
Mhm.
So
When I worked, I did a job. I worked for Algoma Steel for a while, and just before I got there, they had a room full of VAX equipment, like a room full of these big drives, like you say, platter drives and tape backups, and walls and cabinets full of equipment in this whole room. And the room was, I think it was like 14 feet by 30 feet, something like that. Great big huge air conditioner to keep all this stuff cool. They ripped it all out and they put a little folding table in the middle of the room with a box on it that was about 14 inches cube, and it replaced all of the equipment that used to be in that room. and outperformed it like 10 times. So they named it, I forget what they had, but then they named that guy the Borg Cube. And it ran the tube mill for Algoma Steel at that point.
Yeah. I wonder if that equipment was based on vacuum tubes, not transistors or something.
I don't know. I did see some core memory one time, and I was impressed you would launch that on a moon mission.
Oh yeah, VCF Southwest is coming the end of May. I can't guarantee because who's going to be there. But the first time I went a couple of years ago, Cat had some core memory, and one of them he said it was operational. Well, it wasn't working when I saw it, but he said it was operational earlier in the day, and that's those as finicky as those things can be, right? It was there, and I'm like, that's cool, man. Little metal donuts everywhere, iron donuts. It's fantastic.
Little ferrite beads.
Yeah, little ferrite beads everywhere. Yeah.
I saw one of those. Somebody had a kit for one, and I think I'm trying to remember if it was like a 64-bit array of them that you could kit, so you could wire these things up yourself and hook them up and get them to work. And it actually stored whatever it was, 64 bytes.
I can't imagine the level of effort and tediousness that has to be to make that work that I will not do. I'm just going to say that now.
Yeah, I think there were a bunch of current sense amps that you'd send a current in one direction and it would, magnetize a certain way. And, but I think if you wanted to read it, you actually had to try to send the reverse current. And if the current was like a certain magnitude, that indicated that was, who knows, a 1 or 0. And that's kind of bizarre stuff.
So if you sent a reverse current, trying to read it, did you demagnetize it as you were reading it?
I think you actually did. Yeah, that's what I remember anyway.
You probably have to do a refresh cycle after you read it.
Yeah. Yeah. And there might have been different ways it worked, but yeah, that's what I remember. Long time ago.
That was the biggest reason why they burnt out, is because you'd have to constantly reprogram them. And so they were constantly running current, and they would overheat and melt the wires and melt the solder joints.
Really?
That was the main failure mode for the old iron core memories.
I didn't know that.
And so you'd have to go back in and resolder them.
Hang on, Houston, we got a problem. I'm just resoldering the memory.
Yep.
Well, does anyone else have a robot topic tonight?
Did somebody talk about the robot rodeo?
Yep, Trish gives an update.
Okay, cool. I will tell you, was it?
I talked about it, that Harold might be able to give you guys different insights since he got to talk to all the kids.
I will tell you right now that let me tell that out of the way.
Oh, good.
I will tell you right now, Saturday was fun. It was amazing. Sunday, not so much, because Sunday's the day we have to advocate for the kids and deliberate and all those sort of things. And part of my high I, which I'm a cheerleader, enough of that, a little bit of that goes a long way. So, but we had some fantastic people in there doing that, worked it through on the whole thing. And as great as much a pain Sunday was, I'd do it all again because Saturday was such a great day. It was such a great day. And in fact, I volunteered. I told Trish to call me. I can't verify I'm going to work, but if I can, I will help. And I suggest everybody here do this, because I will tell you right now, if you have never done these things, and if you want to get a whole bunch of hope, you want to refill your battery full of hope for the coming generation, or at least as long as some of us are going to be alive, go interview these kids and go hang out with them. They're passionate. They have a great idea what they're talking about. They do a lot of research on the thing, and ain't none of them, even the ones that are just, there, ain't slouches. These are the higher end of the kids that we're going to run up against, and I think they're fantastic. I think unfortunately somebody has to win and somebody's not going to win, but it's just it fills me, the passion, the energy just recharges all kind of hope batteries everywhere. And I was a bit taken aback because I've seen the first robotics competitions, and they move a little bit slower because they're 150 to 200 pounds. Some of them takes a little bit more mass, and they don't tend to collide as much, even though and their field's a little bigger. These fields are a little smaller. These bots are fast, and I thought I was watching mechanized rock'em sock'em robots. They weren't doing battle bots. They weren't trying to tear each other apart, but let's say they were moving with intention to get out of my way. I got points to score, and it was I was a little taken aback how aggressive it seemed to me, but everybody was doing it, so I thought that was normal. That was just, I'm not used to seeing it. It's fantastic.
Yeah, Harold, the game's different every year, and this year for this particular game, it's just it's defensive and offensive this year, so they don't normally whack into each other as much as they do this season.
Yeah, because it's like that whole not only is it important to do a thing to get you points, it's important to take away points where you can from the other person because they have ability to do that, and not let them get them back. And the only way to get them back is basically to push the other person out of the way. I get why it happens. I was taken back a little bit because I didn't expect that amount of aggressiveness going on in these games. It wasn't battle bots, but it was a good rock'em sock'em time. That's for true.
So did you guys have to wear safety glasses because of all the VEX parts that were,
So the drivers actually do. So they have 3 members of each team serves as the drive team, and they have to wear safety glasses. And there was an event I worked at a couple of weeks ago where I was on the field a lot. And one of the things I was supposed to do was pick up the shrapnel as it came flying off the field. And I had a laundry basket full of parts that I had to take.
And I suspect, since everybody's been announced so far, and when I say this, it gives you hope. Let me tell you, there was something, it was a judges award, right, Trish? Where a team would have won if they didn't stop because another team's robot fell over. They stopped what they were doing, uprighted the other team, their enemy team, and put it back together. And the judge's note from the field said this team would have won if they hadn't done that. So
that was the sportsmanship award.
Yeah, it's sportsmanship award. That's awesome. The fact that it just happened. Then nobody had to ask anything. They just did the thing, and that's part of the hope. That's part of the hope that fills me up on that. So, if Trish asks next time, there needs to be a bunch of you people on this thing right here to volunteer because it's a hell of a day.
It's amazing. And I got pages and pages of the guy that's the QA engineer for ASI Robots. He gave me all kinds of advice on how to make deliberations work better because I've never had a team of 22 people before. Usually it's about 12.
Yeah. Part of the problem when I was saying about Sunday, because you're deliberating, you got people that are passionate about, you got people that looking to do, they're really passionate. They want to do a good job because it's important to these kids, because some of these kids, if we say the wrong thing or say the wrong word to them, it's enough to make them go somewhere else other than into this engineering stuff. Or if we say the right word to them, it's enough. They're at that point in their time. And I get all of those things, how to make this go better. The problem is every time you have a bunch of judges that maybe they've done it before, maybe not. Alex, by the way, was amazing. That guy you paired me up with.
I've been working with him for about 4 years.
He's amazing. He was amazing. He made it better for me. I think I told him that too, or at least I thanked him a lot anyways. But you have all these volunteers that maybe have done it once, maybe done it a bunch, but everything is subjective. So my scores versus somebody else's scores are going to be different. And the nature of a lot of us people in our engineering going, we need to have an objective thing in a box to do everything in. That's just not going to happen. And so there was a bunch of deliberation about what a point was a point and what a thing was a thing and that kind of stuff. And we're all subjective, even when we try to be objective. My scores might have been tighter or looser than another one's. That's why we're all in that room advocating for our team or somebody we feel. I will tell you, most of my teams that came through me that I interviewed, either the scores weren't high enough in whatever ranking it was in ranking that needed to be for that particular award. But of the couple times we had a good discussion, it was on there. So I didn't have to do a whole lot of advocating for teams, but I was keeping an eye out like, oh yeah, we didn't miss, if we'd have missed it by a point or two, I'd have been more vocal on a lot of those things. But most of our teams missed it by like 10 points. It was a big difference. It wasn't enough a difference that I'm going to sit and argue for the team, even though I enjoyed talking to every one of those kids. And I scholars, I keep trying to not say kids or scholar, even though they're kids, they're awesome. But I want to give them some respect on it because they were all respectful to us. And of course the octopus walking around was lots of fun, and all the other kind of stuff that was going on. It was an amazing day. All you people should sign up next time Trish asks. I'm just saying.
Harold, did you see the kids that built the bucking bronco robot to fit
No,
everything?
I didn't.
I'll have to see if I can find some pictures of that.
It was really good. Yeah, have I said a couple of negative things? Sure, but there's always positive and negative. But overall, it was fantastic. I mean, and those are nitpicks. Those are just nitpicks in my personal things, personal pet peeves or annoyances or whatever. And that's in the whole. It's fantastic. Trish does a wonderful job corralling all of us cats, herding the cats in the room, doing what we need to do, and getting us together. And unfortunately for Trish, she's used to being the ringleader, but she couldn't do that. And that was hard for her. I could tell it was hard for you.
Oh,
I could tell
I
it
was
was
trying
hard
to
for
find
you.
that. Yeah, usually I get to be in charge. Usually I'm the head judge advisor, but since my son was competing, I couldn't, and I had to have someone else do it. And he did it completely different than the way that I do it.
Yeah.
And I did not like the way he was doing it.
Yeah. It ended up being all right because we ended up getting through it. But I think that's going to be the same. I think that's going to happen every time. Things are going to be a little different. You just got to kind of roll with those little differences. But in the end, I think we made good choices, and I think we chose well.
Yeah.
Yeah. Which is why we have those deliberations. We all talk about it. And even though I was just whining about it moments ago, that's something that needs to happen. So it's the way of the world, the way that works. So yeah, it's fantastic though. I'm telling you. If you don't sign up next time Trish asks, I don't know exactly where you live, but I can find out. I'll tell you that now. It was good. It was really good.
I told you guys last week when where I live.
It was at the Irving Convention Center.
Yeah, maybe a little difficult for Pat to come down and be a judge. I guess he gets a pass. So
We could
If
send
you
her
wanna buy-
notebooks.
Maybe
If you
Tom.
want to buy a ticket, I'll fly there gratefully.
but no, you could have, Pat, there's a remote section and a in-person section.
Yeah, we could have you score their engineering notebooks.
And some of those notebooks are volumes. They were bragging, oh, mine's 250 pages. No, they found one that had 750 pages in their notebook that needed to review. That was a bit over the top, but and some of them, I guess some notebooks are probably like 2 pages, but those things don't make the carry. So all that kind of stuff. I didn't see any of the notebooks because I didn't want to do notebooks. I wanted to be in person. Yeah, lots of ways to help.
Yes, and I'll add my congratulations to the effort I know you guys have gone through, having been involved in science fairs at the regional and national level for probably 25 years or more. Run them as general chairs and managed a chief judging role and chief safety officer for science fairs, and ours was a large one, typically 400 projects, 200 judges. They're very, very, very intensive activities, and when you carry them off as a volunteer, it's just the most amazing experience. So congratulations, I understand exactly.
It is. Thank you so much. I am so glad that we were too dumb to know how hard it was going to be.
Yeah. The reason I was chief judge for 7 or 8 years was because I couldn't find anybody who would take it on.
You were asking people much smarter than yourself, I'm sure. I know. I get the same way. I mean, I am not smart enough to know when to quit some days. That's just all there is to it. I am not smart enough to do that.
But it's an amazing thing to see year after year, to see kids blossom, do amazing professional caliber work. I've had PhDs who judge the fair, who grab me by the hand and say, you have to come and see this project because these kids in grade 8 are doing better work than my postdocs do.
Well, it's because they don't know. They don't know what they don't know, right? So they go, I didn't know I'm not supposed to be able to do this, but I just tried it and look at something cool. You know, it's awesome.
At one point, I had some university profs come to me and say, can we set up a mechanism where we can get some of these better kids to come and provide reviews of the work that my postdocs and postmasters students are doing and PhD students are doing, because these kids think out of the box, and I cannot get my graduate students to do that. They know too much, so they see these blocks and they can't get away from them. Yeah, we had a lot of fun. A lot of years of really interesting work.
But just to reiterate just a little bit, Trish made this easy on. I was saying it's hard, it is, but Trish made this about as easy as it could be made, and I applaud her work in that. I certainly do.
Thank you, Harold. I appreciate it, and I appreciate you being there.
Yeah, thank you.
And Trish, when it works out that well, what I found was you had no problems getting judges to come back year after year after year because they love the experience. You make it easy for them to judge.
Yeah, that's what I'm hoping. I'm hoping that now we've been established and we had a good event, that it'll be easier to find people next year now that they know what it is.
Yeah, it was cool.
Well, I like the enthusiasm you guys talk about the event. Makes it sound like it was really worthwhile, and it sounds like everybody had some fun.
Yep, we did. It was really interesting on a whole bunch of levels. Not the least of which is you see some kids come in and, you know, unfortunately I did see some kids that are going to be used car salesmen, but that's okay. I'm across a Baptist preacher and a used car salesman myself most of the time, so that's okay. And I know some kids that are going to go on and be high-end engineering people. I could just tell it, as long as they stay the track that I think they're taking, you know. And we need used car salesmen too, but you know, all that kind of stuff. It's just we need all kinds. And but the enthusiasm of being there and wanting to do well and exceed, that's what really stuck with me.
Trish, does your organization have a mechanism for tracking the alumni of the competition? The student alumni?
No, so we are just a group of 9 parents that really like this program. And when the World Championship left and went away to a different state, we decided we wanted to put on our own tournament. So we formed a nonprofit and we just did it. And
that's how I got involved too as a parent.
Yeah, so we have relationships with some of the different orgs, and I know a lot of the kids. Like, one of the cool things for me, there's no way I could have judged because I know a lot of the kids, and I've watched them from 8th grade to seniors now, and so it's been really cool to watch them go from kids that are doing like Lego Storm, and now they're making these incredible robots that do all these things. So a lot of the kids will stay in touch with me, and so I was able to get some volunteers that way. And we did have 2 alumni that came back to judge, and they admitted that they were definitely the toughest judges.
Oh, they were tough. They were really tough, man. They were hammering on these kids.
Yeah.
we have to raise all of our own money to put on the science fair every year.
Yeah, we did too. Well, we ended up taking a lot of money out of our own pockets too.
So once you like when you're a volunteer in an organization like this, you end up doing a lot of everything. So
Yes.
I went back and talked to some of our traditional sponsors and says, what is it that makes you sponsor? And what is it that you believe you're getting out of this? And the thing that they came back and said they wanted to know more about is, where do these kids go after they have this experience? Is it worth it, right? In other words, they consider the money because they want to have scientists and engineers and high level teachers appear in the community and in the surrounding area. And they said, is it worth it? What do these kids do after this? So I started to track that. And you can, with the internet these days, you can accumulate tons of information. And it blew me away how many of these kids go on to do PhDs, to start companies, to do TED Talks at the national level, to do global shattering research, right? It blew
That
me
is
away
so
what these
cool
kids were
because
doing.
you definitely had a part of that. That's amazing.
And then we put together presentations for our fundraising presentations, and that's what gets the attention of the people who are willing to help us. They said, you just proved it's worth it.
Okay.
So I'd recommend you track your alumni and see what they do, 5 years, 10 years down the road. You got to build up some data, but it's well worth it.
Well, the VEX has been around for years, so I wonder if I could just do it based off of that. Yeah, that's a great idea. Thank you, Tom.
Well, guys, any other questions or topics for discussion tonight?
Nope.
Pat, I can show you the massive room full of PDP-11s that I was responsible for in the early 80s. You mentioned the computers at Algoma. I'll share this picture. You might get a kick out of it if that's useful. See if I can find the screen.
Yeah, whatever happened to DEC? Did they get bought out by somebody?
Yeah.
I think they fitted inside an ESP32 now.
Probably.
Is that showing you anything? I can't tell.
Yeah, there's some, I think it's a couple drives at the far end.
Is that you, Tom?
Yeah, that's me. This is from about 1983 or 84. I was responsible for all the automation at this mill, which is a hot strip mill. In fact, that's what the operation looked like, part of it, a little piece of it. And in this room there are 4 1170 PDP-11s from DEC. And we needed 3 of them running 24/7 in order to run the mill. The mill could no longer run with human beings after we got this automation running. And I just happened to be conducting a tour, and there was a photographer who took a picture, and it appeared in a magazine that the company published. So I think you can see about 1/2 of the room. The room's probably twice as big as this, twice as long as this, with these 2 long rows of very large PDP-1170 computer systems with a lot of real-time I/O on them.
That was similar to the tube mill where I was, and you could picture that whole room empty with the 2 big air conditioners in the end over there.
Yeah.
And just a little, 3 foot by 6 foot table in the middle with this little board cube VAX. I don't know what it was, 11780 or what it was.
Yeah. Yeah, these predated the VAXs. These were PDP-11s. The next major system we built was full of VAXs. So the company I worked for was very big on DEC equipment. I'm not sure what else is here. Oh, a science fair. And I think I showed you that one. I don't know what else is in here. I'm not going to flip through them when it's turned on. Goodness knows what's sitting on my hard drive. Okay, stop sharing. Anyway, for what it's worth, since it's a slow evening with robots.
Okay, guys, is that it? Are we done? Well, I want to thank everybody, and for the talks. And Trish and Harold, I thought it was really exciting to hear you guys talk about the competition on the weekend, and I'm looking forward. I grabbed a bunch of the links, and I'm going to go through them after the meeting.
Cool.
So thank you, everybody. And with
Yes,
that,
thank you, guys.
Okay,
I
folks,
guess-
good night.
we will stop the meeting if I can.
Good night.
All right, good night.